Okay, great. Hello everybody. I'm sorry I'm not able to give my talk in Mongolian. Maybe next year. Anyway, I am a mathematician from America, and today I'm going to be talking about what math is like in America. I think there's a lot of great mathematicians from America, but in general, America is actually very bad at math. Um, Compared to other nations in the Organization for Economic Cooperation and Development, which includes most of the developed nations in the world, the US is far below average in terms of our math scores. And this is consistent across many years. Um, in 2018, we ranked 31st out of the 37 OECD nations, and in 2022, we ranked 29th out of 37. Now, the cause of this failure in math, being bad is not a lack of resources. In terms of how much we spend per student, the US is close to the top out of these 37 nations. And in other areas, we are not lagging behind. For example, in science, we are well above average. So it's a question of what is the US doing wrong? And we've tried to fix this problem for a long time. The US has had reform movements in math education for over 100 years, starting in the 1890s with the integrated math was a suggestion people had to alter our curriculum. That didn't end up working out. In the 1930s, there was a progressive math. In the 60s, new math. In the 80s, there were many ideas that led to what's called the math war. 2010s, controversy surrounding a common core curriculum for mathematics. Now, I'm sure there will be continuing movements in the future as to how to improve the curriculum so that the US can excel in math. But I think that the actual reason why we're lagging is not because of the curriculum. There's lots of good ideas as to how to teach well, or how to improve our curriculum and the textbooks. But the real problem is a cultural problem in America. Americans do not like math. You hear, as a mathematician, when I tell people that, the most common response that I hear is, I'm not a math person, or I hate math. People tell me that to my face all the time. American culture discourages learning math. And some surveys have found really surprisingly bad results in terms of Americans' attitude towards math. Over 90% of Americans have some level of math anxiety, meaning they have adverse psychological effects from being confronted with a math problem. And 1 in 3 would rather clean toilets than do math. So Americans really don't like math. And of course, if that's the cultural milieu, then students are going to pick that up, whether or not the curriculum is good. Even with a perfect curriculum, if students are primed to think of math as boring or scary, it doesn't matter how good the curriculum and the materials are. So the question is, some people in America do well in math, myself included. So the question I want to talk about today is, how was I able to succeed? And I think at the core of that is I was actually taught to enjoy math, to think that math is fun. And I think if you think that something is fun, then you can get good at it. So I'm going to talk about my story a little bit. When I was in 4th grade, I was learning long division, an example on the board. And I thought that it was really boring and difficult, and I was frustrated. But, and let's see, yes, I was frustrated, and so were all my classmates. We all thought it was boring, and I think even my teacher thought it was boring, though she didn't tell us that to our face. That was not a good situation, but I was really lucky, actually, because I had a mathematician in my family. My grandpa was a retired math professor, and he recognized that I was struggling with this, and he thought, well, I don't want my grandson to think that math is just boring stuff like long division. So we actually started doing weekly math lessons, he was showing me not how to do long division or things like that, but that math is actually cool. And he taught me many things, and I remember the first one where I realized math can be interesting. It doesn't have to be dry. It was with decimal digits. Every fraction can be written as a decimal with repeating digits. Now that wasn't so interesting to me when I was 10 years old, but what was interesting is you look at the decimal digits for numbers of sevens. Now, it might not immediately jump out to you, but all of them have the same sequence of 6 digits in the same order. 42857, 142857. And that's every number of sevens. It just starts at a different digit. Now, when I was 10, I thought, wow, that's really interesting. I think anybody can look at this and say, that's kind of surprising. Wonder, well, why? And little kids always ask why when they see something strange. So me, I also ask why. Why do we see these cycles? And my grandpa, I'm really grateful to him. He realized that I could understand the answer to that question. It didn't need to just be some weird oddity. It could be something that I understood. And so he taught me branch of math called modular arithmetic, which is usually not taught until college, but it's actually fairly simple. And I was able to grasp why this pattern happens, as well as other patterns in repeating decimals. And it's also applicable to divisibility rules and other base number systems besides base 10. Now, the moral of this story is not that we should teach modular arithmetic instead of long division. Long division is actually also pretty cool. I didn't realize it at the time, but since then I've grown to appreciate it. I remember a couple of years ago, I met an old woman who never got very far in math, but she told me that she enjoyed long division so much that she will actually do long division problems for fun. So I think with the right perspective, even this kind of dry stuff can be really interesting. The moral of the story is that math is fun, even at low levels. We don't need to fake that it's fun. And I think that's where a lot of the problems come in the American math education. We recognize that students think math is boring, and so we try to make it interesting. And I think there's good ways and bad ways to do that. So I'm going to talk about a couple of ways that I see a lot, and I think are not helpful for making math interesting. The first is mixing math and fun together. Now, little kids, we love dinosaurs or unicorns or whatever. And I think it's very tempting for educators to try to mix that together with math so that kids who like dinosaurs will be interested in that. But the problem with this is that kids are very smart and they can see what you're doing. I remember when I was in school, we had this video game that was a Star Wars math game. And nobody played it. I didn't think it was cool. I loved Star Wars, but it was not Star Wars. It was math with Star Wars characters on it. I don't need math to understand Star Wars characters. And this coloring book, I don't want to single this one is like the worst, but there's about 23 minus 4 when there's a brontosaurus, at least when you're 10 years old. You care about the brontosaurus, but not the math. So this doesn't help to get kids interested in that. It doesn't hurt, but it's not interesting to kids if the math isn't interesting. The interestingness should come from the math. So I think another approach that is more common and closer to the mark, but also doesn't really work, is to explain math as a tool only. We think about math as a useful tool for solving real life problems. And that is definitely true. Math is useful for solving real life problems. But again, kids are really smart. And they can tell that most of the math they're learning, they will never use. I've got here survey results as to how much math adults use in the year. You can see that basically very, very few people use math beyond fractions. And that's something you're learning by the time you're in fourth or fifth grade. So students know that they're not using the math. And so this math is a useful tool for solving real life problems. Doesn't work to get students interested in math, unless they're going to be in this 5 sense using calculus. And also, I think the problem with this approach of teaching math as a tool only shows itself if you think about how that would work if you taught other classes like that. Imagine if you taught a music class and your pitch to the students why they should care about music is useful because you need to play music in the background of TV shows or video games. That's true, but it doesn't help students get interested in music because most students know I'm never going to be the one producing a video game or a movie. And the ones who are potentially going to go into music are not going to do it because they could write the background music for a TV show. That's not why music is cool. Music is cool because it's beautiful, it's interesting, it's fun, it's enlightening. And the same thing is true about math. Music and math, and really every field, we teach it not just because it's useful, but because it's beautiful, it's cool, it's enlightening. And I think it's something that I heard a lot of people complain in math class, oh, when am I ever going to use this? But I never thought about it. But the fact I never use anything that learned in history class or biology class either. So why do they only make that complaint about math class? It's because they're taught to think math is just a tool to be used for other things. And they aren't taught to think about other subjects that way. So there is a way to use applications to make math interesting. And I think they can motivate learning. So we usually teach math, like we teach some concepts, and then we teach the applications. I've also seen an application-first method. So you start with a real-world problem, and then you introduce a math technique to solve that problem. I think both of these can work, and they really do help students understand the math, but they don't help the students become interested in the math. The only way this will help them be interested in the math is if they're interested in the real-world problem that it's solving. So let me give an example. You could use exponential functions to model radioactive decay. And normally you would teach this as you're teaching exponential functions, and then you say, hey, we can use this to model radioactive decay. And that's cool, it helps students understand how exponential functions work. And you can also teach it in the applications first method, which is you ask the question, how can we model radioactive decay? And then you use this as an input to teach the students about exponential functions as a way to solve this math. I think the applications first method seems very good, seems very appealing. I've tried it myself, and I haven't found much success. And I think the reason why is because if you don't care about radioactive decay, this doesn't help you care about exponential functions, right? But if you do care about decay, this is great. You need exponential functions. So this helps you to appreciate math because of how powerful it is, but only in the situation where you actually care about the question in advance. And so as a result of this, I've noticed something. I get a lot more interested in math, and I think most students do, when they need it to solve another problem. And so if you're teaching a non-math class and something mathematical comes up, that's on behalf of mathematicians everywhere, I ask you to tell your students to pay attention in math class so they can understand that. When I took physics in high school, we used a lot of ideas from multivariable calculus that I didn't understand, even though I had taken multivariable calculus. But then, when I was learning about electric fields, I realized, wait a second, this math that I learned and didn't really get is the solution to this physics problem. It's kind of interesting. So that's a little bit beside the point if you're teaching math. But if you're teaching a non-math class, you can actually help your students understand math too. I think the takeaways here is, how do we make math fun? Well, you don't need to make math fun. As a math teacher, you should know that math is already fun. When I was 10 years old, I didn't need dinosaurs to make math fun, even though I loved dinosaurs. That wasn't why I was interested in math. I was interested in math because it's interesting. Math is fun by itself. It doesn't need to be mixed with something fun. And then as well, math is a tool for solving real life problems, that's true. But in a math class, that doesn't really help. When you're a student in class, in a math class, and you see some real life problem, you know that it's only there to teach you math. The problem is not what the teacher cares about. I think students, they see these word problems and recognize how contrived they usually are. And they recognize that they're not going to use trigonometry and the quadratic formula in their career. But if there's some problem they actually do care about, it comes up in another class, and requires math, then I think that's a perfect opportunity to get the students interested in that. So I think even if you're teaching a non-math class, you can help your students understand math by showing them where it's useful. And so I want to end by saying something else, which is I think a lot of mathematicians don't make good math teachers because we don't believe that math is fun at the lower levels, right? A lot of people, even mathematicians, think, oh, arithmetic, adding, dividing, that's boring. And so if a mathematician is teaching those classes, it doesn't help. It doesn't help with this problem. You have to believe that what you're teaching is interesting. And I think kids, they can see the teacher's attitude, even if you don't tell the students. And it rubs off on them. What you love, they will learn is lovable, even if they don't love it themselves. So I encourage you to love mathematics if you're teaching it, and love specifically what you're teaching. And the best curriculum and the best resources are not a substitute. All right, yeah, I think we can end it there. Are there any questions?